Hello everyone, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So, today's video is about a quick revision on mathematical physics. So, we have almost covered around 12 topics. So, this is just a kind of quick revision, important points to be noted. And after this, we are going to solve PYQs from mathematical physics, and I'm going to solve like topic wise PYQs. So stay tuned for those videos. And if you haven't subscribed my channel, please subscribe my channel and like all my videos, and also share it with your friends if you like those videos. So let us start. So these are the topics that I have already taken, like these are the topics. And first one was the complex analysis, then counter integration, Taylor series, Lorentz series, Laplace transform, Fourier series, Fourier transform, differential equations, special functions, vector algebra, matrices, and numerical techniques. So if you guys just focus on these topics alone too, you will be gaining like so much marks from mathematical physics. And in my first video of mathematical physics, I have also given the paper analysis, previous year paper analysis, so you can just check that. And these are like most important topics that like every time from these topics there are a question present in our question paper. So I hope you like at least study these important topics for the exam. So let us start with the complex analysis. So if you have to find if the function is analytic or not, you will have to use the Cauchy-Riemann equation, which is given as this. And the Cauchy-Riemann equation in the polar form is given as dou p by dou r is equal to 1 by r dou q by dou theta. So here instead of z is equal to x plus I y, we will have z is equal to r e power I theta. And also a real analytic function will satisfy the harmonic function, which is del square u is equal to 0 and del square v is equal to 0. So if you have any question like given a function u and you have to find if this function is a real part of an analytic function. So if it satisfies the harmonic function, then obviously it is a real part of the harmonic function. And next is the counter integration. There are 4 types of integrations. So basically what are the basic steps to find solve these kind of questions are like we have to find the poles and consider that poles are lying, consider only those poles that are lying within the counter. And also next step is to find the residue. Then use the Cauchy residue theorem, which is given as I is equal to 2 pi I into summation r for anti-clockwise and I is equal to minus 2 pi I into summation r for clockwise. You have to remember these signs. This is going to help you a lot because mostly we mistake for these kind of sign problems. And if in the question there is no information about anti-clockwise or clockwise, you'll always consider it to be anti-clockwise. Okay, so there are different formulas to find the residue. So for the residue of pole of order 1 or a simple pole, you can use these 2 formulas. Where a residue, first one is residue f of z is equal to a is equal to limit z tends to a, z minus a, f of z. So this is going to be a very easy form to use. And the next one is usually used, the next second one is usually used for exponential functions. So wherever you have some exponential function and you think that okay, how can I use this first type of formula for my residue, then you can always use the second formula. So just remember, you have to use these both formulas to find. It is not that okay, if I study only first formula and that is fine. No, you have to learn both these formulas, and both these formulas are going to help you a lot. And for residue of order n pole is given as this. First one is the most basic formula used, and second one can be used for sine or cos functions when required. Okay, it is also when required. It is not that you have to use this second formula. This is when if you feel that your calculation is going so big, then you can just find just do a series expansion of a sine term or cos term, and then find the coefficient of 1 by t. So mostly like when your pole is z is equal to 0, you can use this kind of series expansion. Like if you have sine z by z, now you can use your series expansion over here. or sin z by z power 6 z power 5. So your pole should be of any order, can be of any order, but it should be z is equal to 0. That will be easy for you to find the coefficient, else you will have to do with using the first formula. Okay, so next for that is the basic one which you can use for closed counter and open counter. And for this second type of integral 0 to 2 pi f of theta d theta, you will have to replace z is equal to e power I theta and cos theta to be 1 plus 1 by 2 z plus 1 by z, and sin theta to be 1 by 2 I z minus 1 by z, and d theta as dz by I z. So this cos theta and sin theta replacements are to be done only in the denominator. So please do not forget that these sin theta cos theta terms replacements are done only in the denominator. So if you haven't seen my video on counter integration, then please kindly check my playlist for mathematical physics. You can find at the end of the video. Please look into that, and you'll have an idea how to solve problems from those type of integrals. So these are few important integrals given over here. So you can directly use these integrals instead of solving for a longer time. And next is from minus infinity to plus infinity. It is also the basic step, but over here we are going to consider only the poles that lie on the upper half of the plane. So it should be purely okay. The pole should be lying on the upper half of the plane. So if your pole is like z is equal to plus I and minus I, then obviously z is equal to plus I lies on the upper half of the complex plane and minus I lies on the lower half. So you are not going to consider the lower half. You are going to say that z is equal to I is within the contour. And if your pole is purely real, okay, like pole is like around z is equal to 2 and it lies on the upper plane also and it's purely real, then you're going to use the Cauchy residue theorem as pi I into summation r. So please remember this one when you're having a purely real pole and it lies in the upper plane of the complex upper plane, then you're going to use this Cauchy residue theorem, which is pi I into summation r. And these below are given like important terms required, which can be helpful for you to substitute in your formula directly. Now next is the Taylor series expansion, which is a very simple expansion, and you'll have a function you'll have to expand using this formula, and that's all. And you have to substitute f of, instead of z you have to substitute a given point. And then Lorentz series expansion, we are not going to solve based on Lorentz series expansion from this formula, but you have to remember this formula, because you can have questions like, okay, which of the following represents the Lorentz series formula. So you have to know this formula expansion, and you can check my video on Lorentz series, how to solve a problem on Lorentz series. Next is the Laplace transform, the very important topic over here, because Laplace transform is a very easy and important topic in mathematical physics, because if you have a question based on Laplace transform, even in 5 marks, you can easily gain those 5 marks. You don't have to miss just because you don't know the properties. So you can check my videos for Laplace transform and Fourier transform, all those. I have explained in detail about the properties, and here I have just given some of the important properties for Laplace transform. So the first 3 are also important. Basically, will basically use all these properties. So yeah, this f of x plus nt is for a periodic function, and f prime of x is for a derivative function. So if you have any derivative, like you have a differential equation and you have to solve that differential equation, you're going to use this f prime of x. And the next one is the periodic function x plus nt. That is, if the function repeats itself after some period, then you're going to use directly this formula. And u of x minus a is a unit step function. So for any unit function, you can directly use this formula. You don't have to work out. It is just easy. And even if you don't know, you don't remember all these properties, then this first equation gives you how to solve your Laplace transform for any question. You have to just directly substitute over here the given function and you're going to find it. So, but you have to remember for this periodic function, because if you try substituting in your function and then you derive for this formula and then you solve for your question, then it is going to be a time taking process. So you have to just remember this periodic Laplace transform property. And these two above here, L inverse represents the inverse Laplace inverse transform. So these are like, I have given only the important terms, and for sin x, cos x, cos hx, all those you can just look into my videos, or you can just search into your any book, mathematical physics book, where you can see the properties of Laplace and note down all those terms that are usually learned. Next is the Fourier series. This Fourier series is like basically like formula based and like problematic. You have to perform all those step by step process. So there is no any kind of property where you can just directly substitute and you're going to get the answer. So but basically you can find it first. You can first see that if the function is even or odd. So if the function is even, you can use bn to be 0 and directly find a naught and an. And if your function is odd, then very good, bn you have to only find bn, a naught and an will be 0. So that is the basic thing that you have to find. And other than this, this is a very easy topic where you just have to put in your function and integrate. That's all. And next is the Fourier transform. Fourier transform is also like similar to Laplace transform. Only the formula differs for each. So you can directly learn the main formula where you have to substitute the function and get the value. But these are some of the important property for Fourier transform similar to Laplace transform, where you can use in order to directly find your answers. Next is the most important topic, which is differential equation, because differential equations are such kind of topic that every year you're going to get one question from this area. So differential equations are of first order, second order. So for first order, there are like 4 types: separation of variables, homogeneous, linear differential equation, and exact differential equation. So here for separation of variables, you have to separate, if you can separate, you have a given function dy by dx is equal to x by y. So now you can separate your x alone from to the left hand side and y alone to the right hand side. If you can do that, then you're going to use this separation of variables and you're going to integrate and get the values of y and x. Like you're going to get the values of y and find the equation. And next, the homogeneous differential equation. If your equation satisfies this property, that is dy by dx is equal of it, if the equation is of this form, the given question is of this form, where dy by dx is equal to f of x comma y by phi of x comma y. So only condition over here you have to remember here is where f and phi will have the same degree. Okay, so if it follows this form, then you have to substitute your y to be bx and dy by dx as v plus x dv by dx. Then this will make it easy for you to replace your separate your x to the one side and v to the other side, and you can use the separation of variable form. Next is the linear differential equation of first order, where the equation will be of this form, and we basically get question from this type. So the solution, basic solution is y into integral factor, which is equal to integral factor into q dx plus c. C here is the constant of integration, and the integral factor if is given as e power integral p dx. Okay, next is the exact differential equation. So the differential equation should be of this form, where m dx plus n dy should be equal to 0, and you have to remember if your equation is of this form, then this is the condition used to find if your equation is exact or not. We may have equations of this kind, but only if this condition is satisfied, then that particular equation is exact. So this is the condition, and if they both are equal, then the solution is as this: m dx plus n dy. So this is an easy solution. See over here, m dx, you're going to take y as constant. You don't have to integrate y. So if you have any term like x square plus y dx, then you're going to consider y as constant. You don't have to integrate your y. And then in this next n term, take only those terms which do not contain x. So over here, if I say that my n is x square plus y square. So instead of taking my x square term, I am going to consider only my y square term, and I am going to substitute instead of n. So y square dy will be my integral. So this is an easy solution and easy to solve, but we basically don't get from this exact differential equation, but it is useful for you to know how to solve such kind of questions, so that if in case in future we are going to get questions from this, then this is going to help you a lot because it is an easy topic. Next is the differential equation of second order. There are of two types. One is homogeneous and non-homogeneous. And homogeneous will be equal to RHS will be equal to 0. For non-homogeneous, the RHS will be equal to some function of x. And for homogeneous function, the solution will be y is equal to CF, where CF is the complementary function. And for non-homogeneous, the solution will be CF plus PI, that is complementary function plus particular integral. Okay, so how do you find the complementary function? You'll have a given differential equation and you're going to write the auxiliary equation for that. And this is a quadratic equation, so you're going to get the two roots, m1 and m2. So based on the roots, we are going to see what are the solutions. So if m1 and m2 are real and equal, this is the solution. Y is equal to a e power m1x plus b e power m2x. If m1 and m2 are real and equal, that is m1 is equal to m2, then y is equal to a plus bx e power mx. If m1 and m2 are complex number, that is m1 will be x plus iy and m2 will be 2x plus iy. So the m1 and m2 will be two different complex numbers. So the solution is same as the first one. And if m1 and m2 are the complex conjugates, that is if m1 is x plus iy and m2 is x minus iy, then y will be of this form where alpha is the real term and beta is the term with the imaginary number. Okay, so next is the solution for particular integral. So if your r of x, that is RHS of your non-homogeneous equation, is equal to exponential term, then this is the property form to find your particular integral, where pi is equal to 1 by f of t e power ax. So f of d is the equation that you write for your differential equation, that is d square y by dx square is written as d square and so on, right? So that is your f of d. So instead of d, you're going to substitute a. Replace it by a and you're going to get the answer. But if your f of a is equal to 0, then you have to differentiate your f of t and then substitute your a. And again, if your f prime of a is 0, then you have to differentiate again f double prime of a and you're going to substitute for a. Okay, so next, if r of x is polynomial of x, then what do we do? You have to just directly substitute your f of t, and then you will try to use the binomial expansion for such kind of problems, and then after that you will have x power n term along with q. So when you multiply your d square with x term, whatever polynomial is given over there, so when you try to do that, you'll have to differentiate how many times is required. So if it is d into x, then you will have to differentiate once. But if it is d square into x, then you'll have to differentiate twice. Okay, next is the r of x if is equal to cos ax or sin ax. Only these two terms over here. Then you'll have to use this f1 by f of d square sin ax, and instead of d square, you're going to substitute minus a square. And if minus a square is equal to 0, then you'll have to differentiate and again find. That is f prime of a minus a square should be. You'll have to find the differentiable. Okay, next r of x should be equal to your exponent into polynomial. If it is as such, then what you'll have to do is you have to replace your d by d plus a. Okay, and then after doing that, for polynomial, what do? We just expand using binomial expansion, right? So after substituting by replacing the d by d plus a according to our exponential, then we have to expand by using binomial expansion and then use the same step as we do for what is that? Binomial, that is polynomial pi. So next is the Wronskian. So if you have like two terms, two solution y1 and y2 for a given differential equation, and if you have to find if the particular solution is linearly dependent or independent, you can directly find the Wronskian, where these are the Wronskian y1, y1 prime, y2, y2 prime. So if it is equal to 0, then the two solutions are linearly dependent, and if it is not equal to 0, the two solutions are linearly independent. And also this is an important form of your Wronskian. So you just note it down. Next is the Cauchy-Euler differential equation. So I think it was asked in the last year or before that. So if your equation is of this type, that is x square d square y by dx square, x dy by dx, y such that. So for those you have to replace x by e power z and x dy by dx as dy, x square d square y by dx square as d into d minus 1 into y, and so on. So that is the basic thing, and you're going to get either in a homogeneous form or in a non-homogeneous form. Then you have to solve for that. So the special functions in my special functions uh, video, you'll find the all the properties for Legendre, Bezel, Logger, and Hermite. So you'll have to note down all those in your formula notebook. So you'll have to learn all the recurrence relation, the polynomial form, the orthonormal properties, everything, and mainly the equation, the form of the equation for each of these special functions. So next is the vector algebra. So again in vector algebra, here I have considered only some of the important points. So dot product is equal to AB sin cos theta, and cross product is equal to AB sin theta n cap. N cap is the unit vector which is perpendicular to A and B. And n cap unit vector can also be written as del phi by mod of del phi. And this A dot B cross C is a scalar triple product. And if it is equal to 0, then it is the condition for coplanar. And you can find using the determinant also. Next is the equation of plane perpendicular to the surface. So if you have to find like equation of plane perpendicular to a given surface, then you are going to use this particular function, that is the equation, and then solve it for and get the particular equation, which is equation of the plane. Okay. Next, if del dot A is equal to 0, del of like dot of A is equal to 0, then it is said to be solenoidal. The function is solenoidal. And if del cross A is equal to 0, the function is irrotational. And then Stokes theorem, for Stokes theorem, we can convert line to surface integral, and by using this formula. Gauss divergence theorem is converting surface to volume by using this formula. And here Stokes theorem is applicable for only open surfaces, whereas Gauss divergence theorem is applicable only for closed surfaces. Next is the Green's theorem, which is going to be helpful for you. Like if you have a form this type, then you can equate it using this and fine. And next is the most important thing, where you have three vectors and you have to find if they are linearly dependent or not. So if you find the determinant and equate to 0, that is if it is equal to 0, then it is linearly dependent, and linearly dependent vectors do not form the basis. And if it is not equal to 0, then it is linearly independent. So just remember, linearly independent vectors form the basis. So next topic is the matrices. So these are also again the important properties, where trace is equal to sum of eigenvalues, determinant is equal to product of eigenvalues, and characteristic equation. You can directly use this equation instead of using the Cayley-Hamilton theorem. And also the eigenvalues, the properties, and yes, these two last are the very important one. So like if a matrix, in a matrix, if a row and a column is a multiple of other row and a column, then the lambda will be equal to trace, 0, 0. And if the element of the matrix are all equal to 1, then the lambda will be equal to order of the matrix, 0, 0. So the most important properties to remember. You can also directly solve the problem to get the eigenvalues, but if you remember this, then you will have much more time to focus on other problems which are going to be like very time taking to solve. So these properties will help you solve in few seconds. Okay, next, so in order to find the eigenvalues, you will be using this Cayley-Hamilton theorem, and then to find the eigenvectors, again the same. And to solve the function equations like e power a, 4 power a, cos pi a by x, sin pi a by x, or so on, you're going to use this particular function lambda alpha 1 m plus alpha naught I, where e power m is the given question. That is, it can be e power a, it can be 4 power a, anything. So I have just considered over here as the exponential function. It can also be equal to cos pi a by x, anything. So here what do we do is, you'll have to find the eigenvalues of the matrix and then substitute the eigenvalues of the matrix, okay, instead of m. Okay, so if then your equation will be like e power lambda is equal to alpha 1 lambda plus alpha naught I. So after doing that, you'll be able to find the alpha 1 and alpha naught values. After that, you're going to directly substitute in this given equation and you're going to find the RHS. So the last topic to discuss over here is the numerical techniques, and these are the formulas for trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So if you don't know how to solve a problem, you can just check into my last video, which was on numerical techniques. So I have given examples for each of these. You can go through that. And then this is the Newton-Raphson method with the formula over here, and the Newton forward interpolation formula. So from numerical techniques, at least these 5 topics if you learn and you try to solve problems from those, I think that is more than enough for you to at least attend the question and get 5 marks very easy. So I hope you like this revision, kind of quick revision. Yes, it is a quick revision. So this is only important properties given over here. So I hope you like this video. So thank you. Like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell. So see you tomorrow. Ta-da! And yes, just stay tuned for the videos that I am going to post for the PYQs. We are going to solve together the PYQs. So just have a note, a pen, everything with you, all the properties, your formula notebook, everything with you, so that when I solve the question, you can pause the video and start solving by yourself. And if you don't know, then you can solve with me together. So see you tomorrow. Ta-da!